Hey guys, welcome to CPM 3. This is Module 3, Lesson 5. So in this lesson, we are solving quadratic equations by the quadratic formula. Here is your quadratic formula. Now, we've already learned one way to solve quadratic equations, and that's by factoring. Here's the problem with, with factoring. When you would have a problem like x squared plus 7x plus 3, we would look for something that multiplies to our AC, which is 1 times 3, something that adds up to my B, which is 7. Your only multiples of 3 is 1 times 3, but 1 plus 3 is 4, not 7. So because we couldn't fill this in, we would just stop right there and say that this quadratic is prime. Well, because now I have the quadratic formula, I can not only solve quadratics that are factorable, but I can also solve quadratics that can't be solved by factoring. So when we get radicals and decimals and stuff like that, that's where this comes in. So the good news is nothing is prime, everything can be solved. Bad news for you guys is there's a lot of work that comes with this one. So this formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, needs to be memorized. So to kind of help you memorize the formula, I don't know why I blanked on that, to help you memorize this formula, if you guys know that song Pop Goes the Weasel, there's a tune that you can use to go with it. Maybe.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
So hopefully that melody will help you memorize this formula.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, that's enough of that, but you get the idea. So if that tune helps you memorize it, great. If not, I guess ignore it, but it's got to be memorized one way or the other. So the first problem is, of this one, that it's a long formula. Second problem is there are a lot of different ways to put this into your calculator wrong, and there are only a couple of ways to plug this into your calculator right. If you can follow these 7 steps, you will do this correctly. There's a couple other ways you can put this in your calculator and solve this. That's not these 7 steps. But if you follow the 7 steps, you're going to do this correctly. There are so many different other ways that you can put this in your calculator wrong. So we're going to go through these 7 steps. And as we go through these 7 steps, to help us understand what those steps actually mean, we're going to solve this problem as well, okay, as we go through. So step 1 is to put this into standard form. What do we mean by standard form? You want all of the junk on one side of your equation, and it needs to equal 0 on the other side. Now, of course, it can be 0 equals ax squared plus bx plus c. It just has to equal 0 on one side or the other. Okay, so just like factoring, needs to be into standard form. So when I look at example 1, x squared plus 11x minus 12 equals 0, is this in standard form? Yes, it is. So step 1 has already been done for us. Okay, so that's done. So step 2, label A, B, and C. So if you notice, it's AX plus BC, plus BX plus C. If you have it in order of x squared x, no x, it's always A, B, C. So here, if you don't see anything in front, there's a known 1. So my A is 1. My B is what's with the x, so 11. And then my C is what has no x, so negative 12. So I want you to notice two different things with this. First, I have no variables in my a, b, or c, right? This isn't 1x squared. It's not 11x. It's just the coefficient. I want just the number in front. Second thing I want you to notice, if there is a negative, you need to carry that negative over with it. So because my c is a minus 12, you've got to have that negative in it. It changes everything if you don't. So that is my step 2. Now, once you get better and more familiar with this, you don't have to continue to list out what is A, B, as C. But until you get familiar with it, it is a good idea. 3, substitute the values for A, B, and C into the formula. So I have my formula written here, and I cannot stress to you, it's a really good idea every time you're solving a problem in MyMathLab, every time you are solving a problem in your small group packet, anytime you are solving a problem, write this formula down. The more times you write it, the better it's going to be, or the easier it's going to be at memorizing this. So in place of all of these variables, we have blanks right here. So substitute what they equal where they are. So you got negative b. My b is 11. Plus or minus the square root of b. B is still 11. So 11 squared. Minus 4 times, what's my a? My a is 1. Times c. My c is negative 12. So that negative goes with it. And then all over 2a. So my a is still 1. So you are plugging in 1 twice, b twice, and then c once into your formula. Okay, and I do want to kind of make a note before I get too far in here. Notice the formula says it's all over 2a. It's not just the square root over 2a. It is all over 2a, that negative b plus or minus included. Okay, so that is step 3. Step 4 is really important, and this is where I seem to see a lot of mistakes start happening. Simplify under the radical, not including the radical, just under it. So if you notice here, when it goes over to this next step, it still has a square root here. So when you put this in your calculator, you are not hitting second x squared for that square root. You are just putting what is under this radical and not including the radical. So my negative parentheses 11 can be simplified to just simply a negative 11. When you put in your calculator, not the square root, right? Just 11 squared minus 4 times 1 times negative 12. You should get 169. Okay, not including that radical, just 11 squared minus 4 times 1 times negative 12. And this is all over 2 times 1. Well, 2 times 1 is just 2. So you're simplifying everything, but specifically what is under the radical, not including the radical. In fact, let's just go ahead and put that in parentheses. Not including radical. Okay. So that is my step 4. Step 5, simplify radical if it is a perfect square. So the square root of 169 is a perfect square. We end up getting 13. If you don't know it, you can just put it in and try it. But I'm going to get negative 11 plus or minus 13 all over 2. Okay, step 5. Now step 6, we're going to split the plus or minus to get our 2 answers. So remember, because this is an x squared, that squared tells me I have 2 answers. And those 2 answers come from that plus or minus. So my step 6 is to split this up. And I don't think I'm going to have enough room to do it that way. So I usually like to split it up like this. But I'm going to split it up down here. So this becomes negative 11 plus 13 all over 2 and negative 11 minus 13 all over 2. Okay, the only thing that's switching signs is where this plus or minus is. So notice my negative 11 is negative 11 on both of those 2 answers. Okay, the only one we are changing is where that plus or minus is. Here's where the bigger mistake comes in. And okay, here's how to put it in the calculator. Put in calculator by putting the top of the fraction in the calculator first. After you put the top in, so negative 11 plus 13, then you need to hit enter. Don't clear anything. Once you hit enter, then just hit the divide sign and divide by whatever in the bottom, in this case 2. Okay, so on this one, okay, this is kind of like last lesson. I can't really show you what to do. So if you're not getting the answers I'm getting, you need to come in and see me. On this first one, you're putting negative 11 plus 13 in your calculator. You hit enter. When you put that in, you should get 2. Keep that 2 in that calculator, then just hit divide 2, and your first answer will be 1. Then put in your second one. So in your calculator, you're putting in the top portion. So negative 11 minus 13, you will get negative 24. Keep that negative 24 in your calculator. Just hit divide. You're not hitting clear. You hit divide 2. And you'll get negative 12. So those are your 2 answers to this problem. When you get whole numbers like that, that does mean that this quadratic is factorable. And I'm not going to do this with many of them, but if we were to do our a times c would be 1 times negative 12. My b term is that 11. So what adds up to 11 but multiplies to a negative 12? We get 12 and negative 1. So then once you factor it, you get x plus 12. X minus 1 equals 0. You set up your 2 equations. X plus 12 equals 0. Subtract your 12 to get your first one of x equals negative 12, which is what we got right here. And then x minus 1 equals 0. Add your 1 over, and you get x equals 1, which we got right here. Okay, so when you get whole numbers like that, that does mean that those problems are factorable. So we could have solved the same problem, a different method, by factoring and then using our zero product property, or zero, yeah. Okay, so let's turn the page. We've got 3 more examples, and we're going to go through these a little bit faster. So if you need to come back to this page and look at your steps, please do so, focusing on step 4 and 7, your calculator portions. And if I'm going too fast in the next 3 problems, again, come back to here and look and watch what I'm doing at a slower pace, and then you can maybe go back and watch. Okay, so we got an A, B, and C. On A, is this in the correct form? Yes, it is. Why is it in the correct form? Because it equals 0. So then what's your A, B, and C? My A is 1. My B is 5. And my C is -6. And remember to include that negative. So my quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So substitute in your values. We've got -b, so -5, plus or minus the square root of b, which is 5 squared. And notice I'm putting that in parentheses. It's a good habit to get into. B squared minus 4 times A times C. And it's not square root over 2A. It is all over 2A. Okay, so now we're going to simplify. When I simplify, bring over your -b plus or minus. We're going to have the square root of some number. And this is going to be all over 2 times 1, which is 2. So I just need to figure out what goes under the radical, but not including the radical. So in your calculator, you're doing 5 squared minus 4 times 1 times -6. So when you put that in your calculator, we should get 49. Okay, now I'm out of room. So I'm going to come right here. So I get -b plus or minus square root of 49 is a perfect square. That's going to give me 7 all over 2. So now split this up into your 2 different answers. So my first one is going to be -b plus 7 all over 2. My second one here is going to be -5 minus 7 all over 2. The only thing I'm changing the sign on is right here where that plus or minus is. This -5 is negative on both of my 2 solutions. So now, when you put this in your calculator, put the top in first, hit enter, divide by the bottom. So -5 plus 7 is 2. 2 divided by 2 is 1. On the top here, -5 minus 7 is -12. -12 divided by 2 is -6. So again, this is another one we could have factored by hand. Now, let me stress to you guys why we're not putting all of that in your calculator. For example, on this one here, if you put that in your calculator as -5 plus 7 divided by 2, your order of operations is going to tell you to divide here first. So you're going to get -5 plus 3.5. -5 plus 3.5 is -1.5. So if you put it all in your calculator, this is what your calculator is going to spit out, because that's what you're putting into it. It follows mathematically order of operations. It doesn't know it's a fraction. Okay, so that's why you have to put this in separately. Okay, let's try B. On B, step 1, is it in the correct form? This one is not because it does not equal 0. So to get this to equal 0, we've got to subtract our 14p over. It's going to cancel over here and leave me with 0. Can I combine my negative 14p with a p squared or no p at all? No, you cannot. So we're going to put this side by side, but put this in squared, variable, no variable. So we have A, B, and C. So now my equation looks like 5p squared minus 14p minus 3 equals 0. Okay, put it in the correct order. That way when you list your A, your B, and your C, it's in order. A is 5, B is negative 14, and C is negative 3. Notice I don't have P's in those, and I have included my negatives when there are negatives. So let's go to our quadratic. We've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, because we're writing this every time so that we get good at this, good at memorizing it. Okay, so plug in your information. We got negative b. Well, notice what happens here. You've got negative, then put in your b. My b is negative 14. What happens with that double negative? That's going to become positive. So I'm just going to write 14. Okay, since it's negative, negative 14. So then plus or minus b squared. On this one, you have to. Did everybody hear me? Have to put that in parentheses. If you don't put that in parentheses, when you have negative 14 squared, that's going to equal a negative 196. But when I put this in parentheses, the way it should be, it's going to be a positive 196. Those are very different numbers. Because I know I would like to have $196 and not owe $196. Two very different numbers. So when you put that in, you've got to put that in parentheses. That's why I told you on this one, it's just a good habit to get into to put that in with parentheses. Okay, so negative 14 in parentheses squared, then minus 4 times A times C all over 2A. So when we simplify this, we're going to have my negative 14 plus or minus some square root all over 2 times 5 is 10. Same concept here. You are putting everything in under this radical, but not including the radical. That's why I have this radical right here. So when you put in negative 14 in parentheses squared on the outside minus 4 times 5 times negative 3, we're going to get 256. Okay, I'm out of room again, so I'm coming down here. $256 is a perfect square root, so we will get 14 plus or minus 16 all over 10. And I will split this up into our two different answers. So I've got 14 plus 16 all over 10. And I will have 14 minus 16 all over 10. So simplify the top first, hit enter, divide by the bottom. On the top, 14 plus 16 is 30. And 30 divided by 10 is 3. That's one answer. Down here, 14 minus 16 is negative 2. Now this doesn't go in evenly, but we can simplify. You can divide them both by 2 to get negative 1/5. Okay, so because I still got regular numbers, even though 1/5, okay, isn't pretty, we don't like fractions, this one is still technically factorable. We didn't learn to factor quadratics like this when a was a number, but this is technically factorable as well. We just didn't learn how to do those. Okay, and then on C. Is this in the correct form? No, it is not. And if you remember, we want this squared term to be positive. So that means I need to move this over and this over, because it doesn't matter if those are positive or negative, but we want that squared term to remain positive. Now it actually technically doesn't matter in the quadratic formula, but just for like factoring purposes, it does matter. So we're just going to stay in the habit of keeping that x squared term positive. So that means I've got to subtract my 9n over and subtract my 1. And when I subtract them from this side, nothing is like terms. So I can't combine anything. So we're just going to put them side by side by side. So we're going to have 11n squared minus 9n minus 1. And now that equals 0. So my A is 11, my B is negative 9, and my C is negative 1. So use your quadratic formula. We've got x squared equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So substitute in your information. Negative b, well my b is already negative, so it's going to turn positive. Plus or minus the square root, you have to have parentheses. Let me repeat myself. You have to have parentheses. So that comes out a positive 81 right there, and not a negative 81. Minus 4 times A times C all over 2A. So now simplify. So my 9 plus or minus a square root of something all over 2 times 11 is 22. So we've got to figure out what goes under that radical. So put in everything here that is under the radical, but not including the radical. So negative 9 in parentheses squared minus 4 times 11 times negative 1 is going to give me 121. Now, that is not a perfect square, so for the first time, we are now skipping step 5. So, now when this happens, I'm just going to rewrite that. 9 plus or minus the square root of 125 all over 22. Okay, and I'll put right here in parentheses, this is just rewrote. Nothing changed. Just jump right to step 6. So this becomes 9 plus the square root of 125 all over 22. And 9 minus the square root of 125 all over 22. When this doesn't come out to be a perfect number, this is when it's so important that you follow those steps on step 7 correctly. You're putting in the top of the radical or the fraction first. You're just doing 9 plus the square root of 125. If you're following along with me, if you're doing this in your calculator, you should get 20.180 and then a lot of other junk, right? Keep that in your calculator. I don't want to round that number. Keep it in your calculator. Hit divide by 22. Let's round to 3 decimals. And we're going to get, oh no, we did this again. I don't know how to get rid of that little box. Okay. We get 0.917. Okay, as my first answer. So then the second one, when you do 9 minus the square root of 125, you hit enter. You get negative 2.180 and a lot of other junk. Divide that by 22, and we're going to get negative 0.99. When you get decimals like this as your answer, that's when these right here are not factorable. Okay. Okay, sorry. So on C, we would come to this problem and we would have to end up writing prime. But now that we have the quadratic formula, we can get our answers. These aren't pretty answers, okay? But we do get some answers. We can figure out what it does equal. All right, turn the page. This is the same thing, but it's one of those MyMathLab questions that I don't want you to get wrong or get frustrated because MyMathLab is being weird. So right here it says use the quadratic formula to solve. The quadratic formula states that if A, B, and C are real numbers, the quadratic equation written in this form has solutions what? What it's wanting right here is for you to write your quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So it looks like this one here is the one. This one doesn't have a negative b. Okay, then you're going to hit enter, and it's going to say to substitute in your information. So negative what? Well, what's my b here? My b is 3. Plus or minus my b, which is 3 again. B squared minus 4. They already wrote in your a, so we need to write in our c. And it's all over 2a, which is 1. Okay, so then you hit enter, and it shows you. So then notice here, they want you to simplify under the radical, but not including that radical because it still has a radical right here. So you're putting in your calculator 3 squared minus 4 times 1 times negative 28, and you should get a 121. Okay, so then it shows you that there. So the square root of 121 is 11. Then it broke up both of your solutions. So you've got negative 3 plus 11 all over 2 times 1. So simplify the top first. Negative 3 plus 11 is 8. And 8 divided by 2 is 4. So that's your first solution. Then over here, Negative 3 minus 11 is negative 14. Negative 14 divided by 2 is negative 7. So because we've got these whole numbers, right, that means it's factorable. So that's exactly what it wants you to do next. It's wanting to prove to you that you can solve this either way. So now solve by factoring. So we're going to come over here. We're going to do our a times c. My a times c is 1 times negative 28. Let me make a fatter x. My b term is the middle one, so 3. So it adds up to 3 and multiplies to negative 28. That is negative 4 and 7. So what is this factor to be? Usually it's x, but because my variable here is m, we have m minus 4 and m plus 7. Okay, and of course that can be switched. And so then it does really the rest for you. It says that they set each of these factor equal to 0 and solve. So they added the 4, subtracted the 7 to get the same two solutions. Okay, so you're going to have that question. It looks like number 10 on MyMathLab. All right, as if this video wasn't long enough already, you have some word problems with these. Okay, and I'm just going to, we've got technically 4 in the lesson. We're going to skip example 4 and example 6. We're not skipping example 3 because not only do you see something like this in your MyMathLab, this is also a test question or a test type of question. So it says an object is thrown upwards from the top of a 200-foot cliff with a velocity of 12 feet per second. The height h in feet, that's some good information there, of the object is thrown t seconds is this right here. So the 200-foot cliff and the 12 feet per second, that's just showing you kind of where those numbers are coming from, okay? But it's not super important. So your question is, how long after the object is thrown will it strike the ground round to the nearest tenth? Okay, well out of that, this is the easiest to explain. So let's start here. Tenth means 1 decimal. Okay, so around a 1 decimal place. Now, because I want to know how long after the object is thrown will it strike the ground. How long means I'm solving for t. And if it will strike the ground, I want you to think about this. Okay, if you're sitting in a chair, it's on the ground. Your feet, they're on the ground. Something is on the ground. If something is on the ground, how high up in feet, since that's what my unit is here, is it off the ground? Are you 1 foot off the ground currently right now? No, you're on the ground, so you are 0 feet from the ground. So when it asks something like, when will it hit the ground? When will it strike the ground? Something to that effect, they are telling you that your height is 0. So when my height is 0, I am plugging in a 0 for my h. So now my equation is 0 equals negative 16t squared plus 12t plus 200. So now go to work. How do you solve a quadratic? Either by factoring it. I don't want to factor with those numbers, or the quadratic formula, so we're going to use that. So, is it in the correct form? It is, because it equals 0. My a is negative 16. Now, because we're not factoring, it is okay that a is negative. But if we have a choice, we always want to try and keep it positive, just so we'll do that when we're factoring, okay? But it is okay that A is negative. My B is 12, and my C is 200. So my formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to just work down. So my negative b, my b is 12, so we got negative 12 plus or minus the square root of b squared, so 12 squared, minus 4 times a times c, and it's not square root over 2a, it is all over 2a. Okay, now I'm going to go up here. So simplify this. I've got negative 12 plus or minus the square root of something. It's going to be a big number. We got big numbers here. All over 2 times negative 16 is negative 32. So, in your calculator, we are putting in what is under that radical. So 12 squared minus 4 times negative 16 times 200. Okay, we get 12,944. That's not a perfect square root. Okay, so split this up. And I'm just going to write on top of this diagram. So we've got negative 12 plus the square root all over negative 32. And we have negative 12 minus the square root all over negative 32. Okay, so put this in your calculator. So negative 12 plus the square root of 12,944. You should get 101.77 and some junk. Okay. Keep that in your calculator. We're not hitting clear. Keep it in your calculator. Don't round. Just hit divide by negative 32. And we get negative 3.2 since we're rounding. Okay, that 8 behind that 1 makes that go up. And what unit are we in? We are in seconds. Now, does it make sense that my bucket's gonna, or what are we talking about? That an object will hit the ground in negative 3.2 seconds? No, that one's not feasible. Okay, so we're throwing out that answer. I can't have a negative time. So that means we need to go to the next one. So negative 12 minus the square root of 12,944 is negative is negative 125.77 and some junk. Divide that by negative 32, and we get 3.9 seconds. That one is a lot more feasible, so this is my final answer. When you do problems like this, you're always going to have one that's negative and one that's positive. You're throwing out the negative answer because it's either talking about distance or time. You can't have negative distance or negative time unless you invented a time machine. Then talk to me and we'll get rich together. Okay, but you're keeping the positives of them. Okay, so you're going to have a test question that's like this, and you're going to have one question on MyMathLab that's like this. Now, I'm not doing example 4, but if you want to try this on your own, again, when will something strike the ground? That means your H is 0. And then it wants to know, when is something 50 feet from the ground? So in this problem, you got 2 problems. Your H is 50, and then it's not in standard form. You got to get it in standard form. So if you want to try those, you can. On this first one, you will get this answer is about 2.8 seconds. And then this answer here is about 2.3 seconds. So if you want to try those to check your answers, you guys can. Okay, and then this one here is going to be a MyMathLab question. You're only going to have 2 word problems. Okay, and this one's a MyMathLab problem, but you won't see one like that on the test. And then we're going to skip this one as well. So example 5 says the number of college students in the United States can be modeled, that's supposed to be modeled, by the quadratic function of f of x equals 22x squared plus 272x plus 15,628, where f of x is the number of college students in thousands. Okay, we really don't need the in thousands. And x is the number of years after after 2000. So we have an A and a B. A says to find the number of college students in the United States in 2010. So, because my years is my x, this means I know what my x is. And to find my x, since it's after 2000, we are doing 2010 minus 2000 to know that x here equals 10. So part A is extremely easy. You are just doing f of x equals, and you're plugging in 10 into both of these x's here. So we've got 22 times 10 squared plus 272 times 10 plus 15,628. So you put that in your calculator and you're going to get 20,548. Okay, and what does my f of x stand for? F of x is the number of college students. So I'm going to say students. Okay, so then part B. Part B says, if the trend described by the model continues, find the year after 2000, so we're solving for x, in which the population of the American college students reach 24,500 students. So this means that this is my f of x. It says f of x is the number of college students. So 24,500 is my f of x right here. So now I have 24,500 equals my function 22x squared plus 272x plus 15,628. How do you solve quadratics? Either by factoring, don't want to factor at those numbers, or quadratic. Either way, they got to be in standard form. So that means I've got to subtract this over. Its like term is this 15,000, so I'm going to subtract it from this. Forgot a 5 up in there. Okay, that cancels. We've got 0 equals 22x squared plus 272x minus 8,872. So now my A is 22, my B is 272, and my C is negative 8,872. Okay. Because I'm not using, I'm not going to solve this problem down here, I'm going to use that space down there. So I'm just going to kind of okay. So this going down here. So we got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So my b is 272. So I've got negative 272 plus or minus the square root of 272 squared minus 4 times A times C and this is all over 2A. So simplify this. We have negative 272 plus or minus the square root, I'm going to guess, of some huge number, all over 2 times 22, which is 44. So put in your calculator. You got 272 squared minus 4 times 22 times negative 8872. Yep, we're going to get 54,720. Okay, so now split this up. We'll get negative 277 plus the square root all over 44 and negative 722 minus the square root all over 44. So put that in your calculator. Okay, when you hit enter, you should get 652.51 and some junk. Keep that in your calculator, and then just hit divide by 44. And we're going to get 14.8, and x is talking about years. Now I told you there's always going to be one positive, one negative. This is our answer. But I always like to check, and when you put this bottom one in here, you're going to get negative 27.2, and you can't have, a negative 27 years. So I know that that is wrong, and that I can cancel that one out. Now, just like before when we had year ones, you can't just say the answer is in 14.8 years. So let's just go ahead and round that to 15 years. Okay, about 15 years. And because my years is after 2000, that means we need to do 2000 plus 15 to say that it is about 2015. Okay. This has already been a long lesson, and I'm sure your brain is mush by now, but we still have one more thing to go over. We have something called the square root property. And the square root property says that when you take the square root of something, up until this point, we've only been saying it's the positive version, but you actually have two answers, right? A squared means you have two separate answers. So, for example, if I have something like the square root of 100, up until this point, we have only said that it is 10. But there's actually another answer, and that is negative 10, right? Negative 10 times negative 10 is still positive 100. So you can shorthand that by this plus or minus sign, saying plus or minus 10. And that includes both of them. So, your steps for solving this is to get the squared term by itself on one side of the equation. Okay, so like right here, that squared term is by itself. This squared term is not by itself because it's got that minus 50 with it. Okay, so get it by itself. Once you do that, the opposite of squared is square root. So we are going to square root shouldn't be there. Square root both sides of the equation, and then you are going to apply the square root property, which says you have plus or minus the answer. So, example 7 says, use the square root property to solve. Round to the nearest tenth if necessary. Tenth means 1 decimal. So, on A, is it by itself? Yes, it is. So, step 2, to get x by itself, the opposite of squaring x is to take the square root. So, your square root and x cancel. Square root squared cancel, so we're left with x equals. Now when you put in your calculator the square root of 36, it just tells you 6, but that's why we've got to apply the square root property that says I don't just have positive 6, that can also equal negative 6. So my final answer here is actually going to be x equals plus or minus 6. Okay, same thing on B. Get the squared by itself. So that means I need to add over my 484. So I'm going to get p squared equals 484. Opposite of squaring is to take the square root and so now I'm going to get p equals, if you put in the square root of 484, you get 22, but we know we got two answers, and that's plus and minus 22. Now, we solved these differently in the past. When we learned factoring, we just factored this to p plus 22, p minus 22 equals 0. And so then when we did p plus 22 equals 0, subtract your 22 over to get p equals negative 22. And then p minus 22 equals 0, add it over to get p equals 22. So we've been solving these. These are your difference of squares. Okay, this is just another way, and in my opinion, easier way to solve these. Okay, so we have done these before. Here is your x squared term by itself. Yes, it is. So we're going to take the square root of both sides. This one's not a perfect square, so round to one decimal place. We're going to get x equals plus or minus about 4.5. Here is your y squared by itself. Nope. So we need to add 50 over. So we've got y squared equals 50. Take the square root of both sides. And when I round to one decimal place, I'm going to get y equals plus or minus 7.1. On E is my square term by itself. It is not. You've got 2 being multiplied. It's 2 times g squared. So the opposite of multiplying by 2 is to divide by 2. So I'm going to get g squared equals 484. Opposite of squaring is to square root. And we've already taken the square root of 484. So we're going to get g equals plus or minus 22 again. And then last one, get that z squared by itself. So the first thing we got to do is add our 30 over. So I'm going to get 3z squared equals 30. Divide by that 3. So I'm going to get z squared equals 10. So then take the square root of both sides. And when I round to 1 decimal place, I'm going to get z equals plus or minus 3.2. Okay, I know that was a long lesson, and in most classes we don't split this up into 1 lesson, so this is probably a 2 rotation lecture. Let me know if you guys have any questions, and as always, pause this video and rewind it as much as you need to.